Good morning. Let's get started with a warm-up. Let me go back to our first slide here. If you water 3 sunflower plants with different amounts of water, and the 4th sunflower receives no water, after a 2-week period, the height of the sunflowers is measured. What's the independent variable? Hopefully you remember the independent variable is the thing that we change at the beginning of the experiment. So the independent variable in this is going to be the amount of water. The dependent variable is the thing that we measure at the end of the experiment. So the dependent variable is the height of the sunflowers. Here's something else that we also need to remember for what we're going to do today. The formula for speed. Remember, there are 2 things needed to calculate the speed of an object. We need distance and time. So for the formula, we just divide distance and time to get speed. Today, we're going to take this a step further by adding a graph. Yoda is going to help us learn it. So we're going to watch him as he walks to and from his doghouse, paying careful attention to the graph. Here's Yoda. He's going to help us learn how to graph motion. Remember those 2 things we needed to calculate speed? We put them on the axes of the graph. Distance goes on the y-axis and time goes on the x-axis. Here, Yoda starts walking away from his doghouse. Hopefully, you watched what happened as he got further away from the house. Did you notice the purple dog as he walked away? The further he got from the doghouse, the greater his distance increased on the graph. Let's draw a new graph showing Yoda going home. Notice the closer he gets to his doghouse, the more his distance decreases. And here, Yoda is moving very slowly. What do you notice about this graph? Hopefully, you noticed that the line was much less steep. Now look at how far he went away from his doghouse. He only went about half the distance he's been going in that same amount of time. That's going to make the graph less steep, covering a short distance in a long time. In this graph, Yoda is demonstrating moving very quickly. He's only moving about half the distance again, but look how quickly he got there. He covered the same amount of distance in a much shorter time, which makes the graph very steep. Poor little Yoda has been walking a lot for us, so now he's just going to stand still for this next graph. Notice his distance is not increasing or decreasing. He is getting no closer or further away from his house. So his graph is just going to be a straight line. Think about it. Why is the line continuing to move forward even though he's not? Well, that's because the movement on the graph to the right shows time. We can't make time stop. Time keeps going even if we aren't moving. So a distance time graph with a flat line represents the object not moving. They're not moving, but time just keeps going on and on and on. There are 2 great big no-nos that will never, ever happen on a graph. If a graph you draw looks like one of these, you know you did something wrong. In this first graph, we're going to show Yoda trying to time travel. We can't do that yet. He can't go back in time because, remember, we just said time always goes forward. The second no-no is Yoda trying to be in two places at one time. Notice the time again. It is not moving forward. But Yoda's distance is increasing. That is absolutely not possible. Now that you have a better idea of how the graphs work and what they show, let's look at how some of this information could be better put into words for your notebook. Again, these are called distance time graphs. And in a distance time graph, we expect the slope of the line to show the relative speed of an object. If it helps when we look at these, imagine Yoda in all of these examples. In the first graph, the slope of the line is steep. That shows Yoda moved a great distance in a short amount of time. In the second graph, Yoda's line is not steep. He only traveled a little distance and it took him a long time. When you go just 10 feet in 5 minutes, you're moving really slowly. A line that doesn't have a steep slope is going to help show that slow motion. The last graph is a flat line. Remember, time always moves, so it will continue forward even if Yoda is standing completely still. He is not getting closer or farther away from his house. And here are the no-nos that you need to put in your notebook. Distance time graphs can't show time travel, so the slopes can't go beneath themselves, nor can they be completely vertical. Lastly, here are some graphs to practice on. The first graph shows a sloped line and a flat line. Take a minute and think about how Yoda would be moving. His distance is increasing at the beginning of the graph, so he is walking away from his doghouse. Then his distance doesn't change. It isn't increasing or decreasing, which shows no movement. So here in this graph, Yoda walked away and then stopped. Here's another graph to practice. Think about Yoda when you look at this. Yoda took a long time to go a very short distance, which means he was moving slowly. Then he suddenly moved a very great distance in a short amount of time. So we could say that Yoda walked slowly away from his house and then ran quickly away. All right, here's the last practice. Notice there's something a bit different with this graph. The line moves up, showing an increasing distance. It flattens out, showing a stopped motion, and then moves down, showing a decrease in distance. That's going to show Yoda walked away from his house, stopped, and then went back home. If you haven't already, Click on the notes link on the unit map to write your notes. And then please email me if you have any questions at all. We'll continue to practice these over the next few days. Again, email me if you have any questions.